wanted to set the context with what are the three key things we're going to talk about. What is engineering productivity, and what are we doing to make high-quality software development easier and faster? How do we do this? By adhering to our guiding principles of driving test health, avoiding performance regressions, and ensuring high-quality releases. And lastly, bringing this talk back to a lot of you who are GCP developers and consumers, what are we doing when it comes to Antos, which you heard Sundar talk about and a bunch of subsequent keynotes? What we are doing in terms of engineering productivity with respect to Antos, and how you can benefit from that. What can you walk away from this talk in terms of tools and infrastructure we have built, which you can start using as soon as you step out of this room? So let's get started. So before we jump into things, what do we mean by moving fast and not breaking things? Moving fast is good. It helps you innovate. It helps you respond to critical issues and bugs sooner. It enables better productivity because to have a release train which keeps going constantly, you have to follow the right engineering practices. And lastly, it really makes sure that code health is prioritized for that particular service, or in our case, the entire platform, because you cannot move fast if you keep building technical debt. But breaking things isn't. Why is that bad? It's bad because it erodes user satisfaction. Our customers who use GCP are less likely to recommend GCP to other customers if we constantly break them. It diminishes the brand. GCP is used by a bunch of critical companies and applications, and we need to make sure we have a high uptime and high quality. It makes it hard for us internally, as we have seen a few years back when we started this journey, to really land our features and commitments to the roadmaps we have committed to our customers. And lastly, quality is table stakes when it comes to a cloud platform. When you're working with enterprise customers, quality is table stakes. So as an enterprise, you need to move fast. The expected time for products has shortened dramatically, from years to days in a lot of cases. But again, enterprise customers want quality. To Mitra and me, a good analogy we could think of was transportation and high-speed trains. You want to move fast, you want to get from point A to point B as quickly as possible, but not while you risk safety of the passengers. GCP is a set of solutions and products that helps our customers solve the toughest business challenges. We have external paying customers who run their applications at a massive scale on GCP. Within Google and on GCP, given its open source model, we have a lot of developers contributing to this platform at all levels of the stack. These engineers want a seamless development workflow and want deterministic signals through the workflow process. A quick overview, what is engineering productivity? We started off as a test engineering organization which was focused mostly on the part of the development workflow after code gets submitted and how it gets validated, deployed, and so on. About a decade back, we started pivoting to engineering productivity, and we started looking at the entire software development life stack holistically. We realized it's important for us to get involved right from the design phase and to also make sure that once our features, products, and services are on production, they actually are performing, scaling. Within Google, we use this term landing. Are they landing? It's not good enough to launch. We want to make sure things land. We also started, as Google started getting involved in a lot more things, we started getting involved with applications in the ML and AI space, backends, front ends, mobile. And we've been able to take a lot of the learnings we've had within Google over the last 2 decades and take the best parts of it and actually apply it to GCP and Antos. So let's first ground ourselves in some numbers to give you all an idea of what engineering productivity is and how it fits into GCP and within Google. As you can see on the slide, Google has about 2 billion lines of code and more, 60K code submissions, 800K builds, 150 million automated tests. More importantly, all of our tools are built in-house. Now we are starting to build them in open source. Mitra will go into that. And they use the same technologies as Google products do. They run in the same data centers. Our source stack handles 2 million QPS, roughly. So the takeaway from this slide is it's a massive scale. So what does EngProd do as part of this? To give, hopefully all of you recognize what this is. If you're a GCP customer, you probably use this. This is the Cloud Console. EngProd works very closely with the Cloud Console team to make sure we ship this twice a week. Our goal is to establish bi-weekly high-quality release cadence across GCP. The console's at the higher part of the stack. It makes sense to ship it twice a week. Our low-risk storage systems, core infrastructure systems, we don't want to ship them twice a week. But we do want to ship them with regular cadence for the reasons I explained before. But we strongly believe that internally we want to have as frequent healthy snapshots, in most cases like daily release candidates, as we call it, which gives us the ability to go faster if we need to. So how are we ensuring this? Balancing developer velocity and quality. We have created a set of guiding principles that let us balance developer velocity and quality. We want to share these practices and tools with you all so you can accelerate at the same pace as we do. We really pivoted on a philosophy that we just don't want to be comfortable catching bugs, we want to prevent them. This meant that in addition to doing complex qualification across systems, we started building tooling and infrastructure that enable developers themselves to qualify their code before they submit it. Going back to the notion of preventing things. This changed the way we built, qualified, deployed, and monitored our applications, again, to balance developer velocity and quality. Let's look at what our guiding principles are. Our guiding principles are driving test health, avoiding performance regressions, ensuring high-quality releases, all of which is anchored in insightful and actionable metrics. Let's take a closer look into these principles and see what I'm talking about. With test health, we aim for hermetic integration tests, fast pre-submits, and elimination of test flakiness. Internally, we have built a cloud integration testing framework that incorporates these learnings and principles and enables developers to write tests once and run them anywhere. I'm going to repeat that. Write tests once, run them anywhere. That is important because that has allowed us to really amplify the value of our tests. And because the tests are hermetic, they are fast, they don't have flakiness, and that has really boosted our ability to increase the amount of validation we can do for a feature right from the time it starts getting developed to even how it performs in production. Under the hood, we have a bunch of technologies like resource pre-provisioning, record replay to speed up, setup, and tear down, which for those of you who are in this space know takes up a lot of the time when it comes to integration tests. So let's look at our next guiding principle, avoiding performance regressions. We want to make performance a first-class citizen. We have done that by building a performance benchmarking library internally that service owners and products can seamlessly integrate into their products and get rich performance benchmarks. This is now a standard not only within GCP, but within Google. This, in turn, has allowed us to keep monitoring performance as a feature or a service keeps getting developed, and not as an afterthought once we put it on production and then figure out, oh, it doesn't scale or it's slow. Lastly, our third principle, ensuring high-quality releases. We wanted to take this slide as an opportunity to say that there's a balance between tooling and process. As much as effective tooling is important, and we have built a bunch of great tooling in this space, I think we have learned that effective process is important when it comes to high-quality releases. We have distilled the problem on GCP that if the rate at which we push our features from development to production, if you're doing that well, you're ensuring high-quality releases. We have learned a bunch of best practices. We wanted to share a few of them with you all here. One of the most important things we realized is if you decouple the features and the binaries, that really helps your binaries and your releases to be a release train, one that goes out every day, every week, depending on the service. And if there is a certain problem that shows up in production, it's mostly guarded behind a feature flag. You can just turn off the flag, and the releases keep going out. This also helps us really install the engineering discipline we need for the last bullet here. If there is a problem introduced not by a particular feature, there is some global state in the architecture. We have the culture to figure out what caused the problem, debug it, find the exact change, revert it, cherry pick the change that caused the problem, let the train keep going, and go fix it and put it in the next train. This ensures that we are not taking shortcuts for critical fixes, critical P0s, and so on and so forth. Most importantly, we measure all of these via metrics. I read this somewhere literally half an hour back. I thought it was good to share it here. If you don't know where you come from, you don't know where you are. If you don't know where you are, you don't know where you're going. If you don't know where you're going, you're probably going somewhere wrong. That brings me to project health. We balance developer velocity and quality at Google and on GCP via project health, which we refer to as PH. We track key metrics across developer productivity, release velocity, reliability, and most importantly, quality. We automatically calculate a project health level, a pH level, based on all these metrics. We have years of data at Google and within GCP that the higher a project's project health level is, the better they do at balancing developer velocity and quality. A higher pH means better development practices. A higher pH means a better ability to fix issues. A higher pH means you can focus on coding and not pushing releases because they are automatically going on, and so on and so forth. Let me ground this with a concrete example. Here's an example of a project health dashboard for a particular area in GCP. This is the view the service area gets, saying these are all your projects, here's your overall project health level. This gives them an ability to zoom into one of these areas and figure out which one of these metrics they are struggling in and what they need to devote their resources on. As engineering productivity, this is also very useful information for us, because very often there are a lot more developers working on a service than engineering productivity engineers working with that service. So this helps us prioritize our efforts and figure out what are the hotspots for this particular product or area and zoom in on that. So recapping, guiding principles are driving test health, avoiding performance regressions, make performance a first-class citizen, not an afterthought, ensure high-quality releases, both via effective tooling and process and engineering discipline, and measure everything. I'll invite Mitra now to talk about what we are doing along these principles when it comes to Antos, the tools we have built, and how you all can benefit from them.
Hi, everyone. The outside world now uses VMs, Kubernetes, GitHub, and containers. Google's software traditionally used to be stored in a single shared repository, but our landscape is continuously changing, and we need to evolve to adapt to this changing landscape as we are building tooling for Antos and further on. So let's look at open source development. Google works very closely with Kubernetes and Istio open source communities to develop a lot of tools to improve development velocity as well as quality. We contribute very actively to SIG testing in Kubernetes. Let us dig a little bit deeper into the test infrastructure along the same guiding principles that you saw Ankit talk about just now. Driving test health. In the open source community for Kubernetes, we helped build the continuous integration system called PROW. PROW started in 2016, and we replaced Jenkins as the system for Kubernetes. Why is this important? Because we no longer need to run a Jenkins master, and we can update the service without any downtime. Another important thing is that we test Kubernetes on Kubernetes. It is very easy to maintain and deploy and respond to GitHub webhooks rather than using a munger. Test grid. So test grid provides a grid of test results, which gives you very fast access to test results. You can also highly configure this to look at all the bug data and sort through data and get data about grouping or filing bugs and so on. This is integrated with Cloud Build, and so you can go to Results Store to view all of the Cloud Build results and logs and do more analysis on the data. Let us see what we have done in the space of hermetic infrastructure when it comes to open source. Some of you may be familiar with Kubernetes and Docker. This is another open source tool available for use to you in Kubernetes. This provides hermetic testing via a local Kubernetes cluster that you can run on your development workstation. There are no external dependencies, and it helps you integration test Kubernetes applications with other things like Istio or Nomos and so on. Let's see a quick demo of how Kind works in action. I'll give you a second to observe this. Yeah, as you can see, the cluster gets created really quickly and basically creates an entire Kubernetes cluster in the matter of seconds when you compare that to a cluster on cloud, which takes about 4 to 5 minutes to start up. Avoiding performance regressions. We want to make performance a first-class citizen, like Ankit was just talking about. We want to provide you the ability to visualize performance data and catch regressions really quickly. And so we are working on open sourcing tooling that lets you visualize performance data and find these regressions just as we do for GCP. This graph shows the trend for a performance benchmark, and you can see that there is a developer checking in a fix, and then that caused the performance regression to be fixed, and then the curve came down again. And this kind of lets developers collaborate with each other around performance. We've already deployed this to some of our customers, and we are working to bring this to open source. Talking about high-quality releases, I wanted to highlight how Jenkins X uses Prow for CI/CD alongside the Canadia build pipelines. Let's walk through the process a little bit. A developer creates a PR. The GitHub then sends the PR notification to Prow. Prow creates a build on Canadia, and it runs the Jenkins file pipeline, and the results get uploaded to result store. So this is one of the ways that you can automate your full CI/CD pipeline using Prow and Jenkins X on open source. And let's take a look at actionable metrics. Kubernetes was essentially designed for software portability and like developer portability. To kind of ensure consistency and portability when we move across cloud providers and cloud, we worked with Kubernetes for the CNCF, which is Cloud Native Compute Foundation, as you might know, and helped design or implement the conformance program. This infrastructure lets you measure the end-to-end coverage when it comes to Kubernetes APIs and visualize the results of coverage over time. This is all integrated into test grid, so you can view the coverage numbers for Kubernetes APIs. We've also enabled this for Canadia. And so here you can see a graph that shows you how the coverage numbers trend over time, and you can see the results on test grid. And then moving on to a hybrid cloud model with Antos. We wanted to make sure that as the landscape evolves to support hybrid cloud and multi-cloud, we use the same CI/CD and tooling processes to also test a hybrid cloud platform. So we make use of the same CI and CD systems with Prow, Result Store, and so on, and make sure that we can also test on-prem the same way we test on GCP. Let's take a little bit of a closer look at the qualification pipeline for Antos. So a developer has code in his repository, and this is the system under test. So we want to make sure that you are testing your pre-submit flows and submitting the code. When code gets submitted, a git checkout happens, and we run an on-prem cluster of Prow on a vSphere lab, and then this creates a GKE cluster, runs all the tests, and then publishes the test results to test grid. Once the developer submits the code, we also run tests on post-submit. Certain tests are run pre-submit and some on post-submit. And you can basically see how Prow again runs the tests and publishes the results to test grid. So this helps us really easily interpret the CI signal towards release readiness. So to summarize again, engineering productivity makes quality software development easier and faster. And we do this by adhering to our guiding principles of driving test health, avoiding performance regression, and ensuring high-quality releases. And you saw a little bit about Antos engineering productivity tools and how a lot of them are available for your use and benefit.